The following presentation was recorded at the 2013 SouthEast LinuxFest in Charlotte, North Carolina. It is licensed under a Creative Commons license. For more information about the SouthEast LinuxFest, visit www.southeastlinuxfest.org. The SouthEast LinuxFest would like to thank the following diamond sponsors in 2013 for helping make these videos possible.
Okay, so you're all, oh wow, it's not good. Okay. You're all in here because you're a video game developer, right? No. Are you in here because you want to be a video game developer? Yes. I saw someone was playing DVD, at least half of you are awesome if you're not actually not already video game developers. So let's get this started here. If you're in the wrong office, is rating video games with SDL 2.0. If you want to go to another talk, all the other ones suck. So just stay here, it'll be fine. That's good. So just a few notes to get started. If you are tweeting about this, the Wi-Fi is working sporadically. If you want to tweet, put that hashtag self2013 so that we can find you and critique your grammar. Okay, feel free to interrupt. If you have a question or a complaint or a disagreement, just yell it out. I'll repeat your question. Probably keeping swear words in it, and we'll go from there. But feel free if you have anything, just throw it in me. I'll try to respond. This talk will go in a different direction. Slides are up. These slides are at this website right now. We put a lot of work into this web page. You'll really appreciate it. Otherwise, you just read it up here. Don't worry. And last note is that today, this is a very high-level overview. There's like 3 slides of source code on it, so don't panic. If you're not even a programmer, or if you're thinking about learning to program, just store this stuff because this will tell you that when you want to right to the screen, right to the graphics on the screen, this is what you should be doing roughly. Okay, let's get started on this. Let's see. Okay. What's that? Okay.
I can't type for drinking.
It's join the club. Okay. So who am I? My name's Ryan. If you haven't heard of me before, that's great because I don't really high profile. I'm a game developer. I port stuff to Linux and Mac OS and weird platforms like that for a living. I like to think of myself as a hacker. I don't know, maybe in the nicest form of that term. When I'm not working video games, I'm building tools to help me port video games, and that's my talk tomorrow if you want to see some of those things. Same time, probably the same room too. Probably better than all the other talks also. I'm on Twitter at Nicholas. You can feel free to reply me during this, and I will not see it until I'm done talking. My email address, and if you want to see things I've done, that's my resume. If you don't want to look at my resume, I'll go through this real quickly. I started Loki Games. They ported games to Linux for a living, for a business, and that worked for a while. And then I moved on to their list of Activision, and EA, and Epic Games, and Google, Valve, and now this is my most demanding client right now. She's 16 months old. Takes up more time than everyone else, I swear. Okay, let's see. So let's talk about SDL. Stop talking about my child. SDL stands for Simple Direct Media Layer. I know that's 4 words. Directed media, you just mush them together. It's one word in this. If you want to think of it as what is this thing? It's a library, it's a game framework. It's written in C, it's C callable, obviously. It's very simple to use from all sorts of different scripting languages and from C++ and stuff like that. You want to think of it as the answer to DirectX. DirectX is something that runs only on Windows and technically sort of a little bit on the Xbox. But SDL does this for other platforms. It does it for Mac OS and Windows and Linux and FreeBSD and Solaris and things that you've probably never even thought of writing before, but if you get a homebrew kit for it, like the Dreamcast or the Sony PSP, you can download a free compiler, point SDLX, it already works, and just turn your game at it. Like I said, it's cross-platform, that's great. It's very powerful, it pretty much sets up what you need to do, it gets out of your way, so it's incredibly fast, but it's also very easy to use, and that's where the S is, that's the simple part of Simple Direct Media Layer. I'll give you an example of that in a moment. Now this isn't a fly-by-night sort of thing. We put about 15 years of development into it at this point. Yes, we're only at version 2.0 now. We're very, very methodical about it. It started, well, I'll get to it in a moment, but it's been in many, many games. It's been in little simple games, like the game that guy's playing right there, if he's not playing the web browser version of it, to big AAA games like Unreal Tournament, Quake 3, Doom 3, Quake 4, like big games. It's also been some other ones that have just been coming out recently, like Team Fortress 2, Left 4 Dead 2, Half-Life, etc. like that. So So as I say, many games, millions of gamers. A couple weeks ago, Valve shipped the Linux version of Half-Life with SDL 2, which means that 5 million more people are using SDL 2 now. So, in fact, if you're running a game that's going to run on Steam, they ship SDL with Steam, so it's always there whenever you want to play your game. Whenever you want to run a game that's going to run on Steam. And the website for it is linuxfest.org, if you're so inclined. All right, a very brief history of this. It was started by a guy named Sam Lansing. He still works on this. He's still the primary developer for it. He works for Valve now, which is part of why we're using things like Half-Life. He wrote this originally for a program called Executor, which was an emulator from like Mac OS Classic. Like you can run like System 7 on it or something. It wouldn't even be like Mac OS 9, but it was really awesome at the time if you wanted to play like the Mac version Alone in the Dark or something like that. So Loki Software hired Sam, and they used this. They really put an enormous investment in manpower and money and time into improving SDL and making it into a game framework because they needed to do one thing, that was ship games on Linux. So with that in mind, they couldn't just start from scratch every time. So they had this good framework and they started building it and improving it and stuff like that. And since that's become kind of a de facto standard, we've had it's at the point where you go, well, how do you write a game for Linux? You use SDL. It's kind of a no-brainer. It's what you would start with. You wouldn't, I mean, you can. I wouldn't recommend it. You can talk to the X server directly if you want, and you can talk to Pulsa and OSS and Pulse Audio, or you can just talk to SDL and it will handle all that junk for you. So for many, many years we've been working on SDL 1.2, and we've just jumped to SDL 2.0, which is the new hotness. That's what I'm talking about today. I'll make some references to 1.2 because we have literally a decade of development and games built on it, but mostly we're going to talk about SDL 2 today. So here we go. Here's the features of SDL. The new version, SDL 1.2, the old version, runs on everything. If you have a computer that has a screen that can show graphics, it probably runs SDL. We had Palm Pilots running it. We had, BIOS ran it, and BIOS still runs it, by the way. The Dreamcast and PlayStation Homebrew and stuff like that. They all run SDL. And that came to a very interesting point where if you wrote a game and you focused the cross-platform parts, like the parts that we normally talk to Windows or Mac OS or Linux, instead of running a bunch of if-tests for that, if you just talk to SDL, almost universally those games would just compile and run on platforms you've never seen before, and just work out of the box, which is really great. Modular portability bugs, of course, but that's always a good thing. So it's a portable game framework, as I've been talking about. It has multiple API targets, and what that means is that anyone that's ever tried to use Linux and get their music player to play has probably experienced this over the years, where one day it worked with /dev DSP, and then the next day that didn't work, and then also was there, and you talk to also if you want to make sound. And then one day they want you to talk to also, so now you talk to the Pulse Audio people. And if you talk to the Pulse Audio, if you try to talk to also, still will let you, but it routes it through Pulse Audio, which then brings it back to also. It's ridiculous. And tomorrow there will be another sound API, whatever the next great thing is. But the nice thing about if you target SDL, that API never changes. So in the worst case, we have games that we shipped in the 90s that still are talking to the same SDL audio API. But the way that you talk to the kernel to make noise, to make your sound card go bleep and boop, has changed dramatically in all those times. All you do, drop in a new SDL. Just replace that library and just keep on going. The game itself doesn't need to be recompiled. You don't have to do anything to just make sure that your SDL has whatever the new popular sound API is. And then also just for video APIs, because we've spent many, many years talking to the X server, and SDL does that for you. We're about to have to start talking to Wayland and Mir and whatever Android does and stuff like that. And, well, yeah, we'll talk about Mir later perhaps if you have time. But the point being, you can just drop out the old X11 version of SDL and drop in Mir, a Mir version or a Wayland version of it. The nice thing about that has also been, I lost my train of thought. We're off to a good start. Let's move on. It makes hard things easy. We said that before. It's ZLib license. The old version was LGPL, and we changed it because we started running into problems where people wanted to do things like, well, I need to run this on iOS, but iOS does not let you load shared libraries, which is ridiculous. But that they won't, so you can't satisfy the LGPL requirements on there because you can't ship a shared library version of SDL on it and load it at runtime. Just stupid. Oh, I remember what I was going to say. Multiple API targets, and this is the other thing that's smart about it, is that if you have an SDL that talks to X11, you don't necessarily have to swap it out. You might have a Fox X11 and Wavelet and Mirror and AA Lib. Has anyone ever seen AA Lib? There is an AA Lib target for SDL, so you can play Quake on like Telnet. So no joke, it actually works. It's pretty weird, but all of those go into the same binary, and what SDL will do is he'll open those things at runtime and say, well, this system has an X server, and he seems to be running X right now. We'll talk to X to do video. Oh, he's not doing. We talk to FBCon, like the lower level kernel frame buffer driver, and it'll do the right thing depending on what's on the end user system. So you don't have to have a custom SDL for every single thing. You just have one, it looks at everything they have on the system and does the right thing based on what it sees. And that's true for audio targets. So you might have pulse audio support, the library might not be there, so if I couldn't DL open them, I'll move it on to the next thing. Or like I could DL open it, but they're not running the pulse audio server, move on to the next thing. You know, stuff like that. So it's incredibly flexible in that way. It's really useful. So let's note up there is that this is zlib license. SDL 2.0 is zlib license. And I'll put this up here. I don't expect you to read this text up on this slide, but that's the entire zlib license. I was going to put the LGPL license up here from SDL 1.2, but at 9 this is like 30-point font. At 9-point font, it was like 15 slides. So I figured you probably didn't really want to read that. But the basic gist of the zlib license, for those that haven't seen it, is basically don't claim you wrote this. Give me credit if you want. Don't sue me. In fact, just leave me alone. Basically, that's the license. And this has always been our attitude with SDL2 is that we love it. We love that people like this app, the software, and we hope it's useful to you. And we don't really want to get into the politics of it all, the BSD versus the GPL and stuff like that. We just want to make sure everyone can do what they want with it, and we can keep doing what we want with it. Everyone's happy. So we moved over to this license. Okay. SDL is broken up into subsystems. It's all in one library, but there's multiple subsystems to it. And they're all things that you would expect to find for video game development. Video, getting stuff to the screen, audio, getting stuff to the sound card, input, getting stuff from joysticks, haptic, force feedback, making your joystick vibrate. Platform stuff like threading and stuff, and standard lib, which is, you know, like making sure that SN and printf works correctly and stuff like that. There's a lot of things that SDL doesn't do. It's an incredibly low-level library. It wants to be able to make you get bits to the screen and bits to the sound card and stuff like that, but it doesn't want to build a whole game-making framework on top of that. We want you to take your game-making framework and build it on top of SDL. With that in mind, we've built a bunch of add-ons that are just separate libraries that talk to SDL. You can ship them if you want. You can not ship them if you want. If you don't want them, they're not part of your program. It's no big deal. And there's things like SDL Mixer, which gives you, like a higher level mixing thing. SDL Image, which will load different graphic formats. SDL Sound will load sound formats. SDL TTF will draw true text font text into your graphics if you want it. And then we have RTF if you want rich text format, which is kind of nuts. And then SDL Net, which is less important now, but in the 90s you actually couldn't just use TCP/IP on Mac OS 9. You had to use open sprockets or something. So SDL Net's less important now. It's pretty much everything uses BSD sockets, even Windows. So, but those add-ons are there, and you can just pull them in, and they're all separate and endorsed. Platforms this works on. Okay, we have, like I said, I went through some of these before. We had 1 million platforms for SDL 1.2, and we found out that was really exhausting. Like, nobody had an Amiga to maintain the Amiga with. No one had a BIOS machine that could keep running. No one had a Windows machine that could keep running. We did the best we could. But we said, okay, realistically speaking, these are the things that people are interested in, so these are the things we're focusing on, but these are not all the ones that we're willing to support. But Unix is a no-brainer. I'm at a Linux conference right now. Obviously, we're supporting Linux, and that also means that out of the box, more or less, without much effort, we get BSD and Solaris and all those variants there for Windows. You really want that instead of Mac OS. But Mac OS is supported, Windows, Android, and iOS, which I think are probably going to be our biggest markets sooner or later. Not this year, but sooner or later it's going to be where we all use computers, so we might as well be prepared for it now. Now, if you write an SDL program, you target any of these modules, worrying about things like the screen size. If you get down on a mobile device, your game will probably just work on all these out of the box, which is great. And I'd say other interesting places, like we have a Haiku port. Does anyone ever use Haiku? It's a spiritual successor to BIOS. It's wild. I love it. It runs on that. We actually have a maintainer from the Haiku project that submits patches all the time. What's up?
Commodore 64.
We do have a Commodore 64 port. But hey, you never know. I mean, maybe it could show up, right? I'm sure we could fit this in 64 torches around. Okay. I talked about this already, so I won't spend much time on it, but we picked the target of where audio and video is based on what's on the system and what's available to us. And you know, I'm making fun of Linux, and it's like, look, there's different sound API this week. You know, we have this one, and 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 3 others in the list here. But, you know, who else does that? Windows does that too. You know, they used, they had WinMM, which was like, you know, back when CD-ROMs were like multimedia. That was how you talk to the sound cards on Windows. And that still works on Windows 8. That's still like, you know, the old standard. But then direct sound came, and then direct sound was deprecated in Windows 8. You have to use X-Audio too, which is the Xbox audio API. So even the things that you've come to expect on Windows, they change all the darn time. So, and you know, SDL was smart enough to on Windows say, well, which one is available on this system, which one's getting used. So, moving on, we talked about the S and simple direct media layer. It's simple. Let me give you a simple direct 3D example. If you're not using SDL, if you're talking to the Win32 API directly, like you would do if you're writing a Windows game. Okay, you all can read this, right? This is, you know, you just want to see what the pointer going here. Will this work? There it is. Okay, so you set up your window class, you register that, and then you have to create the window, and then you show it and update it, and then, oh, hang on, there's more here. You got a direct 3D handle, and then you got to check the adapters and enumerate them all, and then make sure they can, hang on. Yeah, okay, and then you got to, okay, good. So there's like 4 pages in this, and what this doesn't show you here, that's just to get a window on the screen that you can start drawing. That's all it is. This isn't any drawing at all. This is just getting the damn window on the screen and start up. You might have seen these if you could read it. To do, respond to failure, blah, 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 function call failure. 15 of those in that thing. So that code is actually much, much longer if you're worried about things failing, which they do all the time. It could simply be that you do not have access to the GPU on Windows, and it's like, well, that failed, just put it in the message box. So they don't check that. So that's probably twice as long when you start doing error handling and cleaning up and stuff like that. All right, so let's do the complex SDL version of this. You all ready for this?
Yes, we know.
There you go. That's it. So, and that will not just eliminate hundreds of thousands of lines of Windows code, but also Cocoa code if you're writing Objective-C for Mac, and you know, X11 code, which also no one should be subjected to. So there you go. So that's all there is to it. You say, I want a 640 by 480 window. It should have hello as its title bar. I want a full screen. I want to be able to do 3D graphics. That's what that does. And you're done. Now, to be fair, I did error checking this too, so you can add 4 lines of C code to this. All right. That is more or less how SDL works throughout all of its subsystems. I just use that as an example because more or less that's, you just say in very simple declarative language, this is what I want to do, and it does it, and it gets out of your way, and it's awesome like that. Okay, so we're going to go through the APIs for this now. The video API is the first one. This is probably the most complicated part of SDL. So there's like 2 little pieces of source code I'll show you in this. The gist of this is you can get multiple windows. You can put as many windows as you want. But we're doing like heavyweight windows, not like, you know, lightweight ones packed into each other, frames and minimize stuff, that kind of thing. You also, in SDL2, get multiple displays. So if you have Xinerama, or whatever they call it, XR&R, and you have multiple X monitors on your desktop, you can pick a specific monitor for that window, or SDL will let you control that. Also, interestingly, this thing right here, this iPhone, as you can see, it's plugged up to that thing. This looks like 2 displays, and SDL can control both of them separately. So you can write a presentation software in SDL, run it on the iPhone, and say, here's my main screen, and also I can draw over here separately from what's going on over here. Because over here, it's just making fun of you guys. Okay. Anyway, so once you have a window on the screen, which is the source code I just showed you, you can draw into that window. And there's different ways you can draw into it. This is where the biggest piece of complexity comes into. SDL is a very simple 2-dimensional API for drawing stuff. You know, we're talking like Super Mario Bros. Stuff. Well, the Super Mario World stuff. You can do sprites and so a couple of little effects, basically. You can use OpenGL directly on it. You can do something fancy. If you're on an embedded device, it supports GLES and GLES2, of course, for this. And believe it or not, Direct 3D also. Now, the 2D rendering API for cutesy little sprites, we don't do software rendering anymore. Even if you're just saying, I want to put a bunch of bitmaps up on the screen, behind the scenes, SDL will either use OpenGL or Direct 3D, depending on what platform you're on. So it'll always be fast. It's not going to be like, well, we just can't copy pixels faster than this. It puts them on the GPU and uses your cool ATI card for all it's worth. And of course, the video API is also where you get your system GUI events like mouse movement and stuff, but we'll talk about that a little later on. Okay, so the video concepts, the video concepts you want to think about with SDL is there's four of them, more or less. You got windows, surfaces, textures, and OpenGL. OpenGL is kind of a full-fledged citizen of this because it's really where you want to be working if you're making serious games. So we make allowances for that in SDL. Windows are what you think they are. They're literally windows on your screen. Surfaces are software buffers. They're memory buffers in RAM full of pixels. You don't want to use these. They're left over from SDL 1.2, which only did software rendering. You can still use them. We allow you to use them, but you have to do an upload to the video card, to the GPU. You have to turn them from surfaces into textures. Textures sit on the video card. Once they're there, they're blazing fast. You can do all sorts of cool operations on them, and they will draw and not having to slow down. I have to wait for the CPU or the GPU to catch up. And then it's OpenGL. So let's talk about the render API very briefly here. It's a simple two-dimensional API. And like I said, what you want to be thinking about here is like Super Nintendo. Maybe a little better than that, but you want to be thinking of like, I'm putting bitmaps on the screen. I can do some very simple things like, copy them between one another, change colors on them, rotate them around, those kind of things. But we didn't want to make this too complicated, so if you're doing complicated things, you really should use OpenGL directly. But if you want to do just simple things, if you want to knock out a Super Mario Brothers clone, or you want to knock out, something like that, where you want to do some very simple effects on the thing, then this is great. You can knock out, Pac-Man in an hour with this, or something like that. But if you're doing something like, say, Doom 12 or something, or Gears of War 14, you should probably not be using this API directly. But behind the scenes, it uses OpenGL if you're on almost anything. It uses Direct3D if you're on almost nothing. But if you're on Windows, we'll prefer Direct3D because OpenGL drivers on Windows tend to be painful. Okay, like I said, the sprite, we call them textures, but you should think of them as sprites if you're an school game developer. It's a bitmap you put in the video RAM and you move it around. Copying it back to or from video RAM is expensive, so you want to upload your textures once and then draw with them from there without making changes in the directory directly. If you need to make changes to them, you want to try and use this API directly so it never has to copy stuff back from the video card. Like, you can do color ops, like I want to change this thing, like I want to make this thing a blue tint or something like that. You want to do things like that. You can blend them together, you can do alpha blending on them, so you can have one sprite, one texture in front of another, and see through the one in the front if you want to and stuff. You can use some very simple primitives. You can do line drawing, rectangles, and filling and lines and stuff like that. And you can do scaling. And this is for two things. One, you can literally scale a bitmap you're drawing this way. You can also scale the entire. You can do what we call logical scale, where you say, I have a game that is always 640 by 480, but just run it at the native resolution that's moderate and scale it up. So I still think I'm dealing with something that's 640 by 480. It's like a postage stamp on my record this way, right? But as far as the game is concerned, taking the whole screen and nicely, it scales it very pretty. There's a linear scaling on it, so it's not like chunky looking and stuff like that. This is for writing simple games fast. If you want more power, you want to use OpenGL. Man, that's a whole other lecture. OpenGL is kind of hard to step into. It's great, they can do some incredible things, but it's really kind of intimidating if you're a novice. So, if you are a novice, make a note to learn OpenGL, but also double the amount of time you think it's going to take. Okay, but speaking of using OpenGL, we'll do this very quickly, just so you understand where SDL fits into this whole thing. You tell it, I want to set up video, I need the video API, create a window, create a GL context in that window, start drawing. Once you're drawing with OpenGL, when you're done, you call it SDL GL swap window to get whatever you drew with OpenGL up on the screen. And there's a little more than that. You can set certain attributes like double buffering and stuff. But we're not going to get into that right now. But more or less, that is all you need to understand. Is SDL gets you a GL window on whatever platform you're on, and it gets out of the way. Now, you can also draw with Direct3D directly if you want on Windows. Because SDL will say, here's your window handle, and then you're on your own. You're back in this 1,000 lines of code. So, but you can do that. We'll set up everything over window management for you, but the actual drawing you can still set up on your own. Okay, enough about video for the time being. What am I doing for time? I can actually see this time on the clock. Oh, flying. Okay, good. Okay, input. Also important for video games. Before you can only do like a movie player, now you can actually, once you have input, you can actually do Tetris or Pac-Man or something. What's that? Smart apps. I'm getting very helpful. Okay, so input APIs. Okay, so you have the operating system events that you expect. I move this window somewhere, I resize this window, I hit a key on the keyboard, I move the mouse, I hit the minimize button, whatever like that. Those come in through SDL, like it'll figure out what the operating system is offering, it'll convert to a standard form, which I'll show you in the next slide. There's also relative mouse mode, where you basically hijack the operating system and say the mouse cursor is now mine exclusively, and no matter how far I move it, it never leaves the window, which seems really silly until you make a first-person shooter and you don't use the relative mouse API, and you move the mouse across the window, your guy goes, and can't move any further because the mouse is off the window. So, but if you have relative mouse mode on, no matter as long as you keep rolling left, it'll keep turning in a circle. So that's actually incredibly important in video games. And what we do on X11 is we actually start using the X input and get the API there and like hijack the mouse control. It's pretty great. There's a touch API, which obviously you're probably not going to use on a desktop Linux machine, but on Android and iOS, you can say which fingers are touching the screen, where are they at, how long have they been there, when have they been lifted up. Gestures are built on top of that. We have something called dollar gestures, which basically you can record very simple things like, swipes across the screen or whatnot like that. When I see these set of fingers move in this pattern, let me know that this gesture has been triggered. So you can make a very simple like Harry Potter spell scheme with it, or other things like that, depending on what you're looking to do. That was Google's Summer of Code project, actually. And then finally, joysticks, as you would expect in video games, in game controllers, which are different. I'll explain why. The event loop, I talked about this, getting stuff from the operating system. This is what it looks like. You say you have something called SDL event. You ask for them in the loop until it stops giving them to you, and then you say what kind of event was it? Oh, did they move the mouse? Did they hit a key? Did they ask to quit the program? Stuff like that. And you can just handle them, or choose not to handle them as you want. It's really no different than checking for events on any other operating system. It's just this happens to work on every operating system because we're talking to the specifics for you, and then we give you a nice general way to do it. So you have one event loop that works on all platforms, which is good. All right, the joystick API works more or less like you'd expect it to. You can have as many joysticks plugged in as the operating system will support, and we'll handle. Do you have a question?
Yeah, I have a question. Does SDL support multiple mice and keyboards?
Not yet. We did briefly, and it was so badly written that we took it out. We're putting that back in for SDL 2.1 because it's something I love. Because I had a separate library written called Mouse for just that reason. Because given the right game and the right friends, it's really fun to have three people sitting there with mice, competing for desktop space and doing all those. So, or playing next to each other, whatever you're into. But we will support that. We don't yet. We actually have stuff left over in the event system where it'll tell you which mouse it was, but it's not enough to do anything useful with it. Like we don't separate them out very well. We're totally adding that. That's the last slide on here, so we're getting to it. Okay, multiple sticks. So there's 8 joysticks you can plug in, you can put in there. You can do this either as polling and say, hey, where is joystick number 5 right now? And it's tilted it up like this. He's got this axis pointing this way or something. Or you can just, every time they move it, send you an event in that, in this event loop. You can also just say, SDL joystick button pressed, or whatever it's called. And then you can unify that right in there if you want. It's either way you want to do it, it's perfectly okay. You can ask for axes. It's not just simply, I have a joystick. I have a joystick that has a forward axis and a backwards axis, and you can twist it like this, and this is really starting to look phallic, so I'm going to stop that. But no two joysticks are alike, so we give you a way to say, like, how many buttons does this joystick have? What are the metrics that make up this joystick, so that we can do smart things with it, instead of just being like, well, the first stick does all the controlling, because that would never work on the next guy that plugs the joystick in. So we give you a way of controlling that. And hats, of course, the things, hat switches that go on joysticks, we have a way to let you get that too. It will tell you when joystick's been plugged and unplugged. Believe it or not, that's new for SDL 2. Before, we just not let you know that the joystick went away. So in the newer version of SDL, you can literally write a game where someone walks up, plugs in their controller, and your game can announce a new challenger approaches, or some more combat thing like that. So that's all good. Now, the problem we found with this is that no two joysticks are alike. And there's a nefarious force at work in the universe called Microsoft. And they have decided that on the Xbox, obviously you have an Xbox controller, but they would like everyone playing a video game on Windows to also have an Xbox controller. So you may have seen a Windows game at some point where you're sitting there with a mouse and keyboard, and it's like, press the green A key to continue. You're like, what the hell is that? Well, it's because they expect you to own an Xbox controller now. And Microsoft has an API for this now called X Input, which is not to be confused with the X11 API called Xinput. But what it does is basically says, it's a joystick controlling API, but all it does is handle exactly one joystick. All it does is the Xbox controller. That's the only thing it does, which is annoying. But what we found is the game developers have started embracing that on Windows, much to my frustration. I guess I should move on. So everyone wants an Xbox controller, and that makes us sad. But the nice thing about this, though, is that what they found is if everyone wants an Xbox controller, then everyone wants to know some basic truths about the joystick that you're using, and leave it at that. What we've set up is something called Game Controller API, which is kind of like the joystick API, but it's much simpler. It assumes you have an Xbox controller, which is sad in itself, but you find out the Xbox controller looks like that, the PlayStation 3 controller looks like that, the PlayStation 4 controller looks like that, everything that MagCat sells looks like that, and more importantly, everything that wants to run on Steam Big Picture mode looks like that. So we're starting to get games where they're like, we just want it to look like an Xbox controller. So what we do is we look at your controller and we say, we know what kind of joystick this is, and we automatically configure it. So when the game says, I want you to press the A button, we know which button that is on the joystick. Now, there's a million knockoff joysticks out there that people can buy for $10 that were made by the lowest bidder in a children's sweatshop somewhere in China. And they all look a little different on the USB bus, and some of them work better than others. And there's little quirks. Like, for example, the triggers on the Xbox controller, those are axes, as if you had like a regular joystick. But instead of every other joystick on the planet, when you're not touching it, that's 0. And then when you go this way, the number's negative. When you go this way, it's positive. That's not true if there's trigger buttons. They're negative when you're setting 0 at 0, which is just frustrating as hell. So the game controller kind of takes care of that and is concerned with that for you. Yes?
So what about PS3 controllers?
What about them?
Can you use SDL to interface with them?
PS3 use it?
Yeah.
Yes, they absolutely work. And they work out of the box and say, oh, it's PS3 controller. And it will say, when they ask for button A, we know that means triangle or whatever it is on the PlayStation controller. Now, the thing is, Steam has embraced this, Valve has embraced this API. So if you ever play with Steam and use Big Picture mode, and even if you don't use Big Picture mode, you should use it for 5 minutes to configure your joystick. Because you go there and say, when somebody asks for button A, I actually use this on my particular joystick. And Valve takes note of that. And when they get enough people, they update SDL, so we have that data already. So we have a list of the most popular controllers. And you'd be surprised that it's like a million things you've never heard of and 10 things that everyone uses. And then also within Big Picture mode itself, they just have a massive database. So when you plug your joystick in, Steam will know what it should look like. And they pass that information on to the SDL game. They don't just update SDL so it work outside of Steam, but if you're running your game through Steam, it passes it on to SDL through an environment variable. Hey, this joystick is configured such and such way. So your game will just work, which is great. I love that. Okay, so it's less flexible though. If you need to use something like a flight joystick and like rubber pedals and a steering wheel, this is not the API for you. But most people just want to use a game controller like it's a game console, and for that, this is much simpler to use and much more effective because you just know it's going to work out of the box no matter what the guy has for your joystick. The haptic API. For those that have never heard this word, like I hadn't before I started working on this, haptic is a fancy way of saying force feedback. When your joystick rumbles or something like that, we can detect joysticks that have that feature and we expose it to you through SDL. And you can say things like, I want this joystick to do a sine wave effect, and there's like 15 different effects, whatever like that. But most people don't really want that. Most people just want the joystick to vibrate a little bit, and just rumble. Oh, I gotta make it rumble. We have a simple API too, that says make the joystick rumble. SDL rumble controller, I think is what it's called. As you would expect it to be. This will also work with mice and force feedback. They're incredibly uncommon, but they do exist, and for systems that support those, such as Windows, unfortunately, you can actually make the mice vibrate. So we have that. But more or less, this is a firing for API. You don't have to spend a lot of time managing it. You can just say, I want this joystick to rumble for 20 milliseconds, then leave me alone. Like, don't even let me know when it's done. Just stop it rumbling when it's done. So we'll call that firing for Okay. Audio. This is very, very low level. Now, a lot of stuff in the simple direct media layer is incredibly simple. You just give me a window, let me draw into it. Where's the joystick? Let me read information from it. The audio API is painful. Intentionally so. Because this is what we needed when we were first writing audio code. Most games had their own mixing. All they wanted to do is say, I have mixed this audio, I figured out where things should be in the world, and I put it into a buffer, and I want it to go to the sound card. So all SDL does is say, all right, give me more data from the sound card, and I'm going to play it exactly like you give it to me. Now, if you want something to do spatialization or distance attenuation or move 3D things through a 3D world and make them sound like they're actually at those places, this isn't the API that does that. This is the API that you build those libraries on top of. In fact, you can target SDL through OpenAL, which is a 3D sound library. All it does is just keep dumping sound data to SDL, but all the actual math, 3D math is going on in a different library somewhere else. But since we're talking about this here, this is low level, maybe a little too low level. I would not recommend this for novices. I wouldn't necessarily even recommend this for experts, but it's there if you need it. It can let you know when multiple audio devices are, it can let you know if one's unplugged, they give you a USB audio thing. And this is actually kind of useful because I love the idea of having like a surround sound speaker set up where people are shooting at you or whatever, a first-person shooter, and then USB headset where you can hear people talking to you as two separate audio devices. SDL can handle that. Incredibly useful in that regard. You can do mono, stereo, 4-speaker, and 5.1 speaker. We're adding 7.1, which is what people think of as true surround sound. That's in the next version. You can do, I don't know, probably boring you all to death here, 8-bit, 16-bit, 13-bit, integer, little endian, big endian, floating point, audio, whatever. Whatever kind of raw audio data you can hand it, it will handle it. Now, if you compress stuff like Bob Vorbis or MP3, that's where your add-on libraries come in. So you can decode it, get the raw, decode the stuff, and then feed it to SDL. It will do on-the-fly conversion. You don't have to do any conversion. If you say, well, I only have data in this format, SDL goes, no problem. We'll pretend to give it in a format we can actually use. And as you feed it to it, it will convert it without telling you to whatever the audio hardware actually wants. So you don't have to spend an enormous amount of time tap dancing with that. But basically how this works is you open your audio device, and you know how to slide with this here. You open this audio device and you give it a callback, a C function, that SDL will call whenever it needs more data to feed to the sound card. So every quarter of a second, that function will fire it and say, give me more sound, give me more sound. And you just fill in the memory buffer every turn, and it'll start playing. So it's not hard, but most things need more features than this offers, like mixing, spatialization, decoding. This is not the API for that. Really, it's very limited. But if you want something higher level, SDL mixer's not bad. If you just want to get I have a bunch of sounds I want them all to play at once, a bunch of WAV files or Vorbis files or whatever. Or if you want full 3D stuff, OpenAL is incredibly good. I like OpenAL a lot. Those are other options besides this. But all right, so some other stuff. We have a threading API, which seems kind of strange because certainly everything supports threading, but every game we ever worked on had the same 5 if steps. If Windows, create thread. If Linux, pthread, create. If macOS, so we made a very simple API that gives you all of those primitives of threading that you would expect, but the same source code will work on every platform, do the right thing. And we have SDL 2 as atomic operations, where you can have things going on different processors, and you can do some very simple things without whole mutex, which tends to be much faster. There's whole books of theory written about this stuff, and it's complicated, everyone gets it wrong, but it's there if you need it, it'll work. You'll figure out the right way to do it, given a platform or a processor, whatever's available. Okay, moving on, actually, we're running out of time pretty quickly. Other APIs that we have. These are all smaller things. The big things you've all seen already. I mean, playing sound, playing video, reading input, those are the things you need for making a game. But there's a lot of other things that's we want to kind of pull out some more FDEFs without building this whole kitchen sink, so we try to find some other things that were useful. Message boxes are the first thing. What do you do when you can't get the window size you want? I mean, you need to put a message box to say, hey, we can't start the game, but how do you put a message box without, use SDL so you wouldn't have to talk to X11. So we have a very simple API for that, so you can do OK, cancel, whatever buttons, and just put up very simple things. Timers, as you'd expect, to keep track of time. You need to do that in video games for some reason, even though I can't do that in my normal life. There's things for getting the ticks, which is how many milliseconds have been running from point A to point B. You can set timer alerts or pass an event through the event queue when a certain amount of time has gone by. Things like that you need to take care of that for you. Power, if you're running on a laptop or a phone, SDL will let you tell how much battery is left, or if you're plugged into an outlet, which is incredibly useful if you want to say, oh, you pull out the plug on your laptop. I'm going to do something less complex so that we burn less electricity, which, by the way, I would love if more games would do. Or just lower the frame rate or something like that, so your battery lasts longer, you can keep playing. Or, hey, just put a little battery meter saying, hey, you're kind of running down here, buddy, you might want to quit soon. RWOps, read-write ops, is a very, very simple abstraction over file I/O. Anything that needs a file in SDL goes through one of these. And it's just a structure that says, like, here's a read function, here's a write function, here's a seek function. So that you never have to get SDL a file directly. You do a memory buffer, or you do a network stream, or something like that. We found that's been useful outside of SDL. So sometimes people build read-write ops structures for other data or other ways of getting data. SysWO is a very simple way. Just you need the actual window handle. It's like, look, I know I'm on X11, I need the window, or I'm on Windows, I need the HWND, or the Cocoa view, or whatever. That just gives you a way to get it. Those things, you absolutely need them. We handle the clipboard. You can put stuff on the clipboard, you can take stuff off the clipboard, because otherwise you have to figure out how to do it for every platform. That's frustrating. And then we have SDL Assert, which is a modern example of technological genius. It's an assert function. It's a very good assert function. I can talk a whole hour on it, but I won't. Okay, the near future. We're almost done. SDL 2.0 is going to be finalized literally within days. We want to do it in May, and we kept coming up with some last minute things we want to do. So we're about to, the API has been locked down for a couple of months because we want to be able to ship games on Steam with it without them breaking if we change the API. So nothing has changed in that regard. We're still fixing some bugs, and we haven't called it official 2.0. That's happening probably next week, like very, very soon. And then we're going to start on SDL 2.1, and we want to talk about some other things you mentioned earlier. Multiple mice, so you can have multiple mice plugged in, everyone can play at the same time, and differentiate between those. Audio capture, be able to record from a sound card, or a microphone on a thing, and whatnot like that, which can be useful for voice over IP, for example. Video capture, we love to be able to hook up webcams, which I'm not sure we're going to get that in 2.1, but we always had this fantasy about playing Quake 3, and every time you die, it takes a picture of your face and sends it to everyone else.
or Amnesia.
Oh, what's that?
Or we're playing Amnesia and then you get scared.
Oh, yes, or you're playing Amnesia. I'm too much of a coward to play that game. It's terrifying. Offensively, the original joke for this in Quake 3, we wanted to call it the cock and ball cam. You can imagine why. People abuse everything, let me tell you. 7.1 audio, which is what's called true surround sound. You have literally 8 speakers, 7 in a subwoofer, or something like that. And right now we only do 6 speakers. It's actually not hard to do 8, we just haven't done it yet. We're going to add that for 2.1. Wayland's coming up. I'm so sick of the X server, I can't wait. Mirror's coming up, I don't know why. Raspberry Pi is fun. Is anyone in here have a Raspberry Pi? It's the best $35 I've ever spent. Runs Wayland now, by the way. They experimented, it's still an X server by default. But we're going to start targeting it. Right now we have a Pandora target. Has anyone ever played with Pandora? Embedded console thing? No. It uses something called EGL for window management. And so does Android. And so does the Raspberry Pi. So we're going to mush all that into one code base and unify that. And then just have all these weird little fun Linux embedded devices that are all just going to work out of the box. It's so cool. And SDL 1.2 compat, which is still in progress. But we're going to take our 200,000 lines of C code that make up SDL 1.2, we're going to replace it with small shell script. No, so we're going to replace it with about 5,000 lines of C code that all it does is deal open SDL 2, and you still get the 1.2 API, but it talks to SDL 2 behind the hood, which makes maintenance easier for us. Also, it makes things like, we're not going to add a way to target SDL 1.2. We're going to do it in the new branch, for example. Full screen in X11 is much better at SDL 2. It's just an ongoing tap dance that we get wrong and then we get a little more right, and then we get it wrong again. But we'd like to get it wrong in one place instead of 2. So we're building a little library to replace the big library. And if you still need to run on Dreamcast, we'll leave the source code up there. But we're hoping to eventually, when you see an SDL 1.2 binary in the Linux distribution, we're hoping it's just there's a front end that talks SDL 2, even though you don't know you're talking to it. And then your requests here. There's other things that you say, I really want this to work better, I really want this feature, or I'm tired of writing platform-specific code for this thing. Let us know. We'd love to hear about it, such as on our mailing list. Here's how you get involved in SDL. We have a mailing list, which is great. It's full of people who are expert game developers at AAA game companies and people that have never touched a compiler before. And I don't say that with any contempt. I think it's great. It's a great place to learn about not just SDL, but game development too. If you ask a stupid question, you will still get a good answer, which is not true in many places in the open source world. So we try to do our nurturing communities, and I think that If you're a newbie today, tomorrow you might be John Carmack. I'm not going to get in your way. I'm going to make sure you get the help you need. So forms, if you hate mailing lists, there's a web form, which is just a mirror of the mailing list. You can use either transparently. They go back and forth. Don't be a jerk on one, so you see it on the other. There's a wiki, which is incredibly good documentation for all versions of SDL. It's maintained by the community, but they are very aggressive about keeping it up to date, including as we've been breaking the API, trying to finalize SDL 2 a couple of months ago. It was just every day people were updating it, and it was always really, like that should be your first stop if you want to see like API reference for what I've talked about today. And bugs, because we have those sometimes. We have Bugzilla. It's exactly where you expect it to be, bugzilla.libsdl.org, and that's, if you have a patch or a problem, that's where we go, we see it, we maintain it, we aggressively try to close bugs in a positive way, not in a kind of, works for me kind of way.
Won't fix.
There will be something, right? So it's like, I can't reproduce it. I mean, you get someone that has a weird version of Windows 95, whatever. But, okay, so that's the whole talk. If you have questions, I will take them now. 1 second. We have about 14 minutes. We have plenty of time for questions. I can talk forever. If you're looking to hire a Linux hacker, I'm here. I'm available. You can find these slides at nicholas.org/self2013. That's my email address, nicholas@org. If you want me on Twitter, that's ridiculous. That's on Google+. You can use that shortener to get to my account. If you're on Facebook, you can blow me. So that's my talk. Any questions? Yes.
This goes back to the game. Does SDL bring the default?
Did you say MIDI? Like MIDI?
Samples.
Oh, music, yeah. He asked if SDL does MIDI, and the answer is no, it does not. But the one add-on library I talked about, SDL Mixer, does in fact do MIDI, and it will do both like software-generated MIDI, like here's a .mid file and play it back for me, and it'll also talk to the OS level facilities. So I think you can actually in fact plug a keyboard into it, and you can read that.
Highgate reads it, just like enter the device and screens.
Yeah, that's hardcore. Highgate actually uses SDL behind the scenes, but I don't think it uses SDL. I mean, it does not use SDL for that particular thing. But you're also using SDL Mixer. I don't know, maybe they are, but that's cool. We didn't include that. So, okay, any other questions? Anything at all? I should put my talk tomorrow too. Tomorrow we're talking about open source tools for game development, which is just a collection of like, here's some really useful libraries, including SDL, but many, many other things besides this that will make your life easier as a game developer. Apparently we've used all the electricity in the building now. You'll have to get off the Wi-Fi, I'm sorry. Any other questions? Anything at all? All right, I think we're good. I'll be around if anyone has any questions. Thank you.
Most enterprises today realize that usernames and passwords alone aren't enough to keep their network safe from unauthorized intrusions. That's why two-factor authentication has gotten so popular lately. It adds that extra layer of protection enterprise networks need to stay safe. But what you may not know is that some two-factor authentication solutions, they're better than others, like two-factor strong authentication with Wicked. Wicked goes beyond other authentication systems by being less expensive, easier to implement, and easier to use, giving you software-based token clients built to run on all major devices and OSs, including iOS and Android. These tokens utilize a public-private key combination that's generated on device, so there aren't any shared secrets flying around for attackers to hijack, or which require any special handling. Instead, all keys are kept secure and private between the requesting token and your server, which you control in-house, making it the most secure way possible to perform authentication encryption. And with an extensive, flexible API, and support for protocols like LDAP and Radius, Wicked works with any enterprise network architecture to protect the IT systems vital to your enterprise. Download your Wicked free trial today, regardless of whether you're considering two-factor authentication for the first time or just ready to ditch your existing expensive key fob system. We can help with easy-to-implement, easy-to-use, strong authentication. From Wicked.
Your customers rely on your website or application. If it's slow or non-responsive, it infuriates your users and costs you money. Keeping your business-critical systems humming along requires insight into what they're doing. Your system metrics tell stories that can reveal performance bottlenecks, resource limitations, and other problems. But how do you keep an eye on all of your system's performance metrics in real time and record this data for later analysis? Enter Longview, the new way to see what's really going on under the hood. The Longview dashboard lets you visualize the status of all your systems, providing you with a bird's-eye view of your entire fleet. You can sort by CPU, memory, swap, processes load, and network usage. Click a specific system to access its individual dashboard, then click and drag to zoom in on choke points and get more detail. Comprehensive network data, including inbound and outbound traffic, is available on the Network tab, and disk writes and free space on the Disks tab, while the Process Explorer displays usage statistics for individual processes. The System Info tab shows listening services, active connections, and available updates. Adding Longview to a system is easy. Just click the button, copy the one-line installation command, then run the command on your Linux system to complete the process. The agent will begin collecting data and sending it to Longview. Then the graphs start rolling. Use Longview to gain visibility into your servers, so when your website or app heats up, it stays up.
When we created Asterisk over a decade ago, we could not have imagined that Asterisk would not only become the most widely adopted open source communication software on the planet, but that it would impact the entire industry in the way that it has. Today, Asterisk has found its way into more than 170 countries and virtually every Fortune 1000 company.
The success of Asterisk has enabled a transition of power from the hands of the traditional proprietary phone vendors into the hands of the users and administrators of phone systems. Using this power, our customers have created all sorts of business-changing applications, from small office phone systems to mission-critical call centers to international carrier networks. In fact, there's even an entire country whose communications infrastructure runs on Asterisk.
Digium has always been about creating technology that expands communications capabilities in ways that we could never have imagined. And that's part of what's game-changing about Digium. Today, we're doing it again, this time by introducing a new family of HD IP phones that extends control of the user all the way to the desktop.
The launch of these new products represents the next phase in Digium's history of innovation. These are the first and only IP phones designed to fully leverage the power of Asterisk. When we first discussed our expectations for building a family of phones for use with Asterisk, our requirements were pretty simple. We asked the team to build the phones such that they were easy to install, integrate, provision, and use. I think you'll soon agree our engineers have delivered on that goal. User feedback is validating that when it comes to operation with Asterisk-based systems, including our own SwitchVox-based product, these are the easiest to use, best integrated, most interoperable products on the market today. The Digium family of phones will initially include 3 IP desk phones, uniquely designed to complement any Asterisk or SwitchVox-based solution. These phones are different for a number of reasons. First, they're exclusively designed for use with Asterisk. Secondly, we've made it really easy to auto-discover and provision the phones. Next, we've made it easy for the phones to access information inside of Asterisk, allowing tight coupling between an application and the phone. Additionally, we've created an applications engine that allows users and developers to create and run their own apps on the phone. And finally, we've done all of this at a very compelling price point. At Digium, we're always thinking of ways to give our customers the best value in business phone systems and also give them the power to create their own solutions for any communications challenge.
We'll continue to push the boundaries, not only to make Asterisk cooler, faster, and more technologically feature-rich, but to make Asterisk and VoIP communications even easier.
And together, we'll change the way the world communicates.
Again. Cloud stacks are everywhere.
This is the way to better utilize all your resources, and it makes managing all your resources pretty easy.
All of the innovation is happening in open source.
The collaborative nature and of the community and the speed at which these deficiencies, these bugs are getting discovered and fixed is a thing that really shows the power of the open source community.
It is global, and it's definitely because of the users.
Community people are extremely friendly and always ready to help.
If you go onto IRC any day, you'll see these guys helping each other out, and they're all doing it like in a selfless manner.
The product is transparent for everyone. Everyone can look at the code base. Everyone can see how CloudStack is being built. Nothing is proprietary. Everything is open.
In many ways, it's absolutely vital to the ongoing health of CloudStack.
The most exciting event in recent memory for me was our first developer boot camp. And our call gave people, I think, maybe 2 weeks notice to come attend. I was expecting 25 or 30 people. So we ended up with 87 people and had to go get more chairs into the room twice.
Everything within cloud computing is commodity and is open source. And so I don't think that you'll see anywhere where open source is not pervasive in cloud computing. And so I think it's an assumption. I think when you talk about cloud computing, you're really talking about open source cloud computing.
CloudStack is a robust solution for large deployments.
You have dozens of data centers and thousands of servers in each data center. Hardware is going to fail, and CloudStack is designed to handle, number one, that mass scale. Number two, it's designed to handle the failure that inevitably happens in large deployments.
We started working on CloudStack over 4 years ago, and it was the original set of people working on it had a background of delivering software to telcos and service providers.
Lots of QA, lots of users actually using it.
High availability is the key feature. Multiple hypervisor support, different network models. You can pick up whatever suits you better.
CloudStack management server can be deployed in different physical machines.
It definitely has a huge footprint. It's being deployed everywhere.
There's a major movie studio that they were using CloudStack. They were using it to transcode video, and I thought that was terribly fascinating. What I found more fascinating is what they did during lunch, where they would spin up 50 or 60 game servers. Then as soon as lunch was over, they would destroy all the instances and go back to doing real work.
CloudStack is vast. It touches so many different aspects, and there's no one person that's kind of like a master of all those realms.
I think CloudStack as a project is going to be one of the leaders, simply because it's some of the most featureful and robust platforms out there.
I don't see any limits to the CloudStack.